Now that we've covered kind of all the boring stuff, more of the things that you kind of just need to know about the Bash terminal rather than the really fun stuff, we can move on to the actual commands that I want to show you that will make your life a whole lot easier when working on the command line. Now, all of these commands are kind of commands that people know exist, but they don't bother to really learn them because they have a little bit more of a learning curve than, say, all the basic commands I covered in the last video. Such as CP for copy or MV for move, CD for change directory, all those super basic commands. You pretty much can't use the terminal without those, so obviously people are going to have to learn that. Now, all of the commands that you see on the screen right here, these commands are not necessarily like essential, even though this is kind of called Bash Essentials. These are not commands that you're going to absolutely need to get yourself around the terminal. That said, they are very useful and they will speed up your workflow tremendously if you just take the time to learn the very basics of them. You don't even need to get into a whole lot of detail, just learn the very basics and you're set. So we will start off with the grep command, which is basically a search tool. So if I go over to my blog, this is Visual Studio Code right now that I'm using, and I was typing some stuff in here. Let me clear the results, enter, let's see. Okay, so if I wanted to search in this file right here, Bash Essentials, for a specific word or phrase. So maybe I wanted to search for, let's make this simple, so let's just find a word. So maybe command. Maybe we're looking for the word command. And you can already see that Visual Studio Code is pretty smart. It's already picking up that there's multiple versions of command. But if we go to the search bar and notice we're only including this file, if you exited out of that, you could actually search the entire directory in all the files for this word, but we're going to actually eliminate all those and just search this file for simplicity. So we want to search for command, and we want to match the entire word and the case. So we click these two options and press enter. And you can see that we have 42 results in one file. So obviously we're only searching this one file, which makes sense why we only have results in this one file, but we apparently have 42 instances of the word command throughout this file. And if we drop this down, it's going to show you all the lines that you're finding these on, and you can click on one of the lines to just get taken to that line to see where it found it. Now, this is a basic search tool. You've definitely used this before, but you probably haven't used it with grep. So grep is the same thing. It is just a search tool, and it does exactly what we just saw. If we go back to the terminal, and I'm in my blog right now, my blog directory, and I want to actually search that file. So let me just go into source post, that's where that file is, and we can actually cat out the bash essentials.md. And so this is just all the contents within the file we just saw. And if we wanted to search for the word command using grep, we could do so pretty easily. Before I actually type it out, I want to go through the basic syntax of grep. So we type grep, and then we give it any options that we want. So maybe W for match the entire word, and I for make it case insensitive. So these are just your options. You can find more options with the man pages, so just man grep, and you get a bunch of options that you can put in there. Anyways, we have grep, then our options, so we'll just match the whole word, and then we want to pass in the phrase that we're searching for. So here's the phrase and then the file that we're searching in, or multiple files. So translated into what we want to do, we want to search for the command, or the word command, in the Bash Essentials file. So we want to make this a match a whole word, and we don't want to pass in the I because we do want it to be case sensitive. We want to search for the word command, and we want to do it in the bash essentials.md file. When I press enter, you can see that it's going to find all the instances of command, and if you added these up, it's going to be the same number of results that we got in VS Code. Now obviously it's a little bit more messy output than VS Code, and this kind of begs the question, why would we ever use Grep if we have awesome tools like VS Code? And the answer to that is you probably should just use VS Code for all of your text searching needs, unless you don't have access to it, which is a very realistic scenario. So if you were maybe logging in remotely to a virtual private server, if you're running a website, you don't have access to all of the graphical user interface tools, and you just have a command line, you're going to need to know how to use Grep. So that is why we would ever use Grep, and why it's important to learn. So right off the bat, you can see the output that we get with Grep. Now that's just a very basic command. We could also pipe output into the Grep command. So this whole concept of standard input and output that I talked about in the last video very briefly is where it's going to start to come into play here. So if we do a little refresher here, in the terminal we work with pretty much three types of data, or I don't actually know a good word to put to that, but you have the standard output, number one, you have standard input, and you have standard error. So standard output, what we abbreviate as std out, and standard error are kind of the same thing. When the bash, or when the terminal receives a text command, it's going to send the text command through the bash shell, and then the bash shell is going to convert that into something the operating system can use. The operating system is going to execute it, spit something back out. If it was successful, it'll spit it back out into some response, and then the bash shell will put that into standard out. So in other words, if we cat bash essentials.md, that is basically going to print the entire file to the standard output. Now if we cat bash and don't finish it, then it's going to pipe something to it's going to send something to standard error. And finally you have standard input, which is probably the most confusing of the three because we can't really see it. So when we execute a command like grep, it can either execute as we just did, or it can take something called standard input. And standard input is something that it basically reads from. And so what we can do is we can cat out bash essentials.md, but instead of printing it to standard out, what we can do is we can use the pipe character, the little vertical line, to redirect the output from rather than putting it to standard out, we can pipe it to the standard input of another command. So for example, we can do that to grep, and if we use the same command line options, so -w, and then we want to search for the word command, we'll get the same exact output. So that's just an example of how we would pipe output into grep. And you could even continue to do this, just do another pipe into grep, and this time maybe we want to search for command line, and you can see that we're going to get a couple results there. So you can do this endlessly, just piping output into the standard input of the grep command. And this works with many other commands, as we'll see pretty soon. Just to kind of recap the grep command, it's just a text searching tool, and honestly you won't really need to use it a whole lot unless you're working in a situation where a text editor like VS Code is not available to you. The next set of tools that we're going to be talking about is that of Sed and Awk. Now these commands commonly get confused with grep because they are very similar to grep, although I am going to try to point out why they're different and why you would use them for different use cases. Now, this topic can get a little bit contentious among the Linux community because as new programming or scripting languages have come to be, such as Python or Perl, that are pretty much superior to Awk, which is actually a complete programming language, it gets a little bit contentious because people basically say, okay, these are two very useless tools now that we have these better scripting languages. But there are certain situations where I think that these two tools can be used effectively, and you honestly don't have as big of a learning curve as you may think that you do. So just as a brief overview, why you would use these two commands, we first kind of have to understand what they are. So Sed is a text stream editor. So basically it's going to look through each line of a document, and on each line it's going to look character by character by character. And this is great for simple text transformations. So maybe you wanted to do a quick find and replace within a file. So you wanted to replace all of the commas with a period. You could do that with Sed very quickly and very easily. Now, if you wanted to get into something a little bit more complex, so a complex formatting or text transformation, maybe you wanted to replace certain pieces of text based on a little bit of logic, then that's where the Awk command would come in, which is not a stream editor. It is actually more of a just a regular text editor where you can go line by line by line, and it basically splits each line into delimited fields. So and you can specify which field to delimit by. So if you have a normal document which just has spaces to separate each word, you would put the delimiter as a space, and then you would have access to each field within a particular line. So the Awk command is great for reformatting a bunch of text, kind of like printing it out into a nice output for you to see, or also some more complex text transformations or formatting transformations. So that would be kind of where Awk and Sed are good to use. Now, let's not get this confused with Grep, because remember, Grep is only a text searching tool. There's no concept of replacing anything within the output. So both of these tools, Awk and Sed, have the ability to not only search but also to replace text, so they can edit files. Alright, so enough with that explanation. Let's take a look at both of the tools. And to do this, I'm going to have a file here. Let me print out what I've got sitting in my working directory. You can see on the left here, there's a bunch of AAPL, which for you finance junkies, this stands for Apple. And these are just stock quotes for the last, or for different time periods. So I just made a copy, these clean files, don't worry about them, just copies. But this first Apple would be the last 5 days of stock data, something like that. So it's a pretty small file. And then the Apple large would be the daily stock prices for the last 5 years. So it's a much, much bigger file, and we can just see this. Let's cat them out. So apple.csv, this is just the stock price. You can see we have the date, open, high, low, close, adjusted close, and volume. And then with the large file, so if we cat out apple large.csv, you're going to see that we have a lot more scrolling to do. And there's a reason why I created both of these files. You'll see that in a second. With these stock files, what if I wanted to replace every comma? So if we remember, when we cat out apple.csv, we have everything separated by commas, which is why it's called a CSV. Now, what if I wanted to replace these commas with maybe something like a space? The way that I could do that is by using Sed. Now, let me go through the basics of using Sed. There are a lot of different modes that you can use, but by far the most commonly used mode would be the find and replace mode. So the way we do that is by saying sed, and then we give it a find and replace. So we start it with S to indicate that we're using the find and replace version of sed. Then we put in a regular expression and what we want to replace that regular expression with. And then finally we have this G at the end, which means we want to replace every single instance of the regular expression in the file. And then you pass on the actual file that you would want to do this in. So for us, we just want to replace all commas, so all commas with a space. Pretty easy. Now, if I just press enter, what it's going to do is print out what our transformation would look like. Now, this hasn't actually edited the file yet, so if I cat out the same file, you're going to see that it still has the commas. To edit the file, what we need to do is throw in a little command at the beginning, or a little flag, that says -i, or edit it in place. So if we enter this command, it's going to actually transform all of the values within that file. And if we now cat out apple.csv, you can see that we have that transformation as a permanent transformation. That was a basic example of how we might use sed. And to be honest, it's probably maybe the only use case that you will ever use it for. But it also has plenty of different commands that you can use. You can just look through the documentation. Go to the bottom right here. This is what we just looked at, this particular one. But you could also do other things like transliterate the characters in the pattern space, whatever that means, not sure. But you can see there's a lot of different things that we can do with sed in terms of text transformation. Now with awk, this is more of a formatting tool. So I pulled these stock quotes for the particular reason because it's great to use with awk because it's all kind of delimited apart. Now to learn the awk command, I think we need to kind of break it out into a specific file. So remember, in awk, the awk command is not actually like a script, it's more of a full programming language. So you can actually write files that have awk code inside of them and then execute those files on the command line. Usually what you'll see when it comes to the awk command is you're going to see something like what I'm about to paste into the terminal. So you'll see something pretty complex like this, which we're eventually going to get to, but at first glance this is just like, whoa, what is going on? This doesn't make any sense, and you certainly don't want to try to learn how to use the awk command when we have this kind of syntax. And this is most commonly found on Stack Overflow. No one's going to take the time to format the awk command because it's supposed to be like a quick and dirty command line tool. But if I press enter on this, what it's going to do is actually print just the first, the second, and the seventh column of my stock quotes. So in other words, the date, the open price, and the volume. And it's going to put some headers on that. So if I press enter, you see that we have nice columns separated by a couple tabs, and we have at the top we have a date, price, and volume headers. So you can see how this was like a really quick way to format only the pieces of information that we want from this stock file. Now, to understand what this command is doing and to actually learn how to use awk, we need to kind of break this command out into a file and talk through it line by line. So let me exit out of this and let's create a awk command file. So I'm not going to put an extension on it. You don't really need an extension here. You just need to touch a file, and then we're going to use Vim to go into that file. Alright, so within this file we're going to write everything that we just saw on the screen, but it's going to kind of demonstrate how to use awk a little bit better. So the first thing that we need to do is learn what an awk comment looks like, and that is a hashtag. So similar to the bash scripting, which we'll kind of cover later, and Python, this is how we use a comment. So this is a comment. Alright, so that is how we write a comment in this file if you ever wanted to do that. And now we can get into the part which is the basis for the awk command. So awk kind of comes pre-built with a bunch of variables that are already they already mean something. You can also set your own variables. We're not going to get that deep into it, but you'll have some variables that come with awk, and one of those is begin. So the way that awk works is it has first some sort of keyword or variable, followed by these little brackets, and everything in the brackets is what's going to get printed or executed on in this particular expression or keyword scope. So the begin keyword is what awk does before it prints or before it does anything else. So if you ever wanted to set some preliminary variables with the awk command, you're going to put this begin keyword, and then within these little brackets, you can enter them down as much as you want. You can actually define some variables. And what we're going to do is define two different variables and then print a header before we do anything with the actual Apple CSV file. So the first one would be fs. Again, this is a built-in variable that awk has, and if we actually look at the command we just wrote, let me exit out of this real quick. If we pull up the command that we had executed, you can see that this like dash uppercase F and then followed by these two quotes with a space in there, that's actually the same thing as the fs variable. And basically what this means is the file separator. So what is the apple.csv file separated by? And that would be spaces, because remember we replaced the commas with the spaces. Okay, so if we go back into our awk command file, and I'm typing wim, not vim, we can see that if we set fs equal to and then a space, then that's going to indicate to the awk command that our file is separated by spaces. Now we can put a semicolon at the end to tell it that we're at the end of this particular line, similar to like a C program, and then we enter down and we can say OFS. So this is another built-in variable for awk, and it indicates what we want to separate our output with. So I want to separate the output with maybe 2 tabs for good measure. So this will just put some space in between our output. And then finally, we have a function built into awk called print. We also have printf like C, but we're just going to use print. And what we want to print is the date, price, and volume headers. So we can say print and then quotes, date, and then we need 2 tabs because remember we separated the output by 2 tabs, so we want to stay consistent there. Date, price, and volume. So that's going to be our header right there. And we could even do add a little nice header under this. So we could say, I don't know, underscore and then tab. And you get the point. This is just going to put some like little, dashes under the header. Okay, so we've covered the begin built-in variable, and again, this is what awk is going to execute first when we look at the apple.csv file. So the next thing we want to do is actually print the output. So one way we could do that is by coming down here and just saying something as simple as I want to print the first, the second, and the 7th pieces of information. So when we put awk automatically splits up each delimited piece of a line into different like variables. So for example, in like if we had a line, the dog ate some food, something simple like that, and we told awk that our file separator was a space. So here's our space in here. Basically, we would have the would be the 1, dog would be 2, and then so on and so forth. You just move up the chain. So this would be $3, 4, and 5. So that's kind of how awk splits up its delimited output, or yeah, whatever you want to call it. And so we could print out those 3 columns by just saying print 1, 2, and 7. And then we, of course, end this with a little semicolon, if we can move over. Okay, so we could just print it like that. And let's go ahead and get out of this file after I add this last semicolon. And let's delete that little space there. Okay. Now the way that we would execute this particular awk command is by saying awk, and then we're going to pass in a little -f and give it the file that we want to pass in and have it execute on. And if I'm not mistaken, I believe that that is pretty much all you need to do aside from actually passing in the file that we want to look at. So what we got right here is exactly what we expected, except for the top. So you can see that we have this whole date, price, volume, and then date, open, close. And if you remember, what we put in was date, price, and volume. We didn't do the whole date, open, close. And the reason is because if you remember, the apple.csv file at the top is separated by the first line has all of these words on it. So the way that with awk we could basically skip the output of the very first line of the file is by adding in a little keyword before this last brackets. So the brackets don't necessarily need a keyword before them, but if we want some sort of condition to apply to what's inside the bracket, we can put it right here. So for example, if we wanted to print everything after the first line, we would say nr. Oh, I'm deleting stuff here. Let's see what we're doing. We are finding and replacing in Vim. I don't know how that happened. Okay, so we have nr, and this is again a built-in awk variable. And you can look at the man pages, just Google awk built-in variables to see what they all look like. And what I'm going to say is greater than 1. So what this means is the awk is going to print lines 1, 2, and 7 only on lines greater than 1. So if we exit out of this file and we say awk, give it the file, awk command, and give it the file that we want to look at, you're going to now see that we have a nice clean date, price, and volume. Now these are a little bit off on the spacing. I'd have to kind of play around with that, but you can play around with that to get the spacing correct. What you just need to know is that awk is a great tool to kind of visualize what a file would look like. And you could see how this could kind of become useful if you're maybe running repetitive reports. So if you run a report on something every single week or maybe every single day, all you have to do is write a single awk script. And again, you can keep it in, we have this awk command, and you can just keep it in the file. And then every time you maybe download a new set of data, you could just run it through the awk command and visualize it pretty quickly. Now, of course, there are other tools to do this. You could do this pretty easily in Python or even Perl. I know Python has a whole data science library, pandas, and you get into data frames and stuff like that. And again, it kind of begs the question, why don't we just use Python or Perl to do this? And the reason, again, is because sometimes you're not going to have Python available to you. And you'll probably need to understand how to use the sed and the awk commands to do these little text editing or text transformation tasks. And this again would apply mainly to if you don't have a graphical user interface, maybe you don't have root access to install Python, whatever the case, you got to learn these two commands, even if it's just the most simple stuff that we just covered. Alright, so we've gotten through pretty much the hard commands that we're going to be talking about. The rest of the commands are fairly simple, yet really powerful. So the one that we're going to jump into now is called less, and this is a tool that allows us to kind of page through different or some output. So if I go to my blog, and then we'll go into the source and post, we're going to look at the bash permissions file again, and if we just cat it out, bash essentials, if we just cat this out, we're going to see all of the output. And so you can see, like, I'm scrolling through this and it's pretty long, so it's kind of tough. If I want to go to and from a specific line, it's pretty tough to do that. I just have to scroll really fast. But if we use the less tool, we don't have to deal with this problem. So let me clear the screen. And now what we're going to do is we're going to cat the bash essentials.md, and we're going to pipe that into the less command. The other way that we could run this would be less bash essentials.md. Either or works, similar to the grep command. So we are in less, the less tool, and you can see we're at the top of the file. Now let me just give you a few of the most common operations. You can always press H for the help menu. You can see all the things that you can do with less. It's very similar to like Vim, so there are some advantages to using less. It's a little bit more lightweight. You don't really have to you don't have to download Vim. Some distributions don't even come with Vim downloaded. So it's lightweight, it's just quick and easy, and you can do a lot of searching and traversing through the file. So we are in the help menu. We can exit that by pressing Q, and this puts us back into less. And now what I can do is a few pretty common commands. So number one, we want to be able to go to the very end of the file. The way we do that is by typing capital G. So that brings us to the end, and if you want to go back up to the top, that is a lowercase g. And that's kind of how you get to the top and the bottom really quickly. Now, if I wanted to kind of go line by line, I'll use the J and K keys. So very similar to Vim, or actually identical to Vim. We're going to use the J and the K keys to go up and down. And we can also scroll up and down through different frames. So if I press spacebar, or I think maybe F, yeah, so if we do spacebar or F, we can go frame by frame downwards in the file. And if we want to go upwards in the file one frame, we can press B, or think of it as back. So we're going up all the way to the top. So that's a pretty useful way to scroll through the output. We're just using spacebar and B to go down and up a single frame. And then probably the best part, this is kind of like a built-in grep within the less command. We can type a / here at the bottom and search for a piece of text. So maybe we wanted to see, what did we search for before? I think it was command. If we want to find all instances of the word command, we can press enter on that, and it's going to take us, we were at the top of the file, so it's going to go down using that /. It's going to go down until it finds the first instance of command. And if we press N, it's going to take us to the next. And then N again, it's going to keep taking us to the next, over and over and over and over again. Okay, and so let's go to the bottom of the file. Remember that is, I believe, uppercase G. That brings us to the end. Now, if we wanted to search up in the file for the command, the word command, what we could do is rather than a /, we just use a question mark. So now question mark command, and you're going to see there's our first instance. It's at the very bottom, and if we press N again, which basically just repeats the search, we can go up one, and we keep going up the file, finding all of the instances of command. So those are just the basics of using less. It takes maybe 10 minutes to master this command, and it's well worth it because it's a great way to kind of search through large files with lots of data in it. So just a quick recap: to go to the top, you do lowercase g, to the bottom, uppercase G. If we want to scroll up an entire frame, that is B. If we want to go down a frame, that is spacebar or F. And let's see, what else did we talk about? We searched with the / or the question mark, depending on if we want to go up the file or down the file to search. And the most important one is H. If we type H, we get a help menu. So that is less in a nutshell, and you can see kind of how that could help you out with a lot of your outputs, especially if you're dealing with a terminal-only environment. This next command, the find and exec command, it's actually just the find. We'll add the exec part at the end. I'll explain what that is. This is my favorite command, and it's going to help you do a lot of heavy lifting in the bash shell. So this is kind of like, I would say, Grep's cousin. And the reason I call it a cousin is because it's not quite the same thing as Grep. And what I mean by that is Grep is basically a way to search any sort of output. So it could be anything from a list of files. So if we type ls and we list all the files in our current directory, that would be considered output. And I can pipe that into Grep and search for maybe public in there. And it's going to find the public piece of text within that output. Now with find, we're actually searching for the actual files, not the text version of output. We're actually looking for the file that exists in your on your computer. So this is the basic usage of find. We type find, we give it a path that we need to look in, so I'm going to give it the current directory. We give it a type of file that we're going to search for, so that could be a file or a directory and a couple others, but usually it's one of those two. We'll go with file. And then we want to search for a name, which we could say actually like an explicit name, so we could say something like instructions.txt, or we could give it some sort of wildcard. So what if I wanted to find all files that ended in .txt? So that's going to look in my current directory for all the .txt files. And as you'll notice, I have quite a few of them, since I actually have in the documents of my home folder is my blog, which has node modules for the Node.js environment, and it has a lot of like licenses and readmes and stuff like that. So if we wanted to maybe specify that search just a little bit, we could find all the readmes within my home directory. So let's redo this command, and we'll say something like readme.txt. And you can see that there's actually only one of them, and it's in the .vs code folder, which is the kind of the configuration folder for Visual Studio Code. Now, what would be more common is probably readme.md. As you can see, there's quite a few readme.mds for Markdown in my home directory, but this gives you kind of an essence of what this find command can do for you. And that's just one example. You can also do a bunch of other things. So maybe I want to find all of the files that all the files that have a permission set of 755 or 775 that are owned by my user Zach. So the way I would do that is find current directory, and we want to give it a type of file. Name will be anything. We don't really care what the name is. We can actually omit that if we don't care about it. So we can just omit that. We can do permissions. What did we say? 775. And then user would be Zach. And it did not find anything. So if we created that permission set for a single file, let me just example.sh, we'll create a file, and then we'll chmod it to 775. And now that is a file that is owned by me. Let's see where it is. Example, where are we here? Now this would be a perfect time for the grep command. So let's go ahead and use that. ls la into grep, and we want to find example. And you see here we have the example.sh, which is owned by the group Zach and the user Zach. And this is the permission set 775. So now when we run the find command, we should be able to find that one file that I own that has a permission of 775. So that's just kind of another example of how we could use this. But of course at this point you're like, okay, great, we can find a bunch of files, but what's the point of this if all we're doing is finding the files? Now this is where the exec part of the find command comes in, and it's really powerful, almost so powerful that I would caution you against using it carelessly, as you could definitely delete a lot of files off of your computer if you're careless with it. So let's type out the man pages for the find command, and we'll pipe that into less just to kind of exercise our new skills. So in less, I want to search for, so / and I want to search for something called -exec. We press enter, and you can see that we get something right there. I'm going to press N to go to the next one, N again to go to the next one, and here we are starting to see what the exec command is. You can see that this is the description of the exec command, and below is a little bit of output. And I think if we go down, press N again a couple times, we're going to find an example of actually using the exec command somewhere. Let's see. Yeah, so right here we see an example of how we would use this command. You can see that what we're doing is we're finding something in the current directory that is a type file, and then we're executing the file executable, and we're passing in this little squiggly bracket. And what that basically means is that every file that it finds in this current directory is going to be placed one by one into these little brackets and executed against the file command. And then finally at the end, this little / semicolon just tells the exec command that it needs to stop executing when it hits this part of the command. Otherwise it would just go into infinity. So let's exit out of less and give this a try. Now, what if I wanted to take all of, maybe, let me see what I would want to do here. I could take all of my pictures on the computer and put that in some sort of folder. So maybe I just wanted to aggregate all my pictures together, or maybe I just want to back them up. So here's what I'll do. I'll say find, I'm going to actually just kind of limit the output here so that we're not getting too crazy, so it doesn't take too long. I'm going to first make a directory that says pictures backup, and that's where we're going to store all of these copies. And then what I'm going to do is I'm going to find everything in the current directory. I think I have a pictures folder, so we're going to look in the pictures folder, and then we're going to say any file type, and the name is going to be anything that ends in PNG. So I'm only looking for PNG images. Now what I want to do with those is I want to execute the copy command, and then I'm going to put the little squigglies here. So I'm going to copy whatever file it finds, and then I want to copy that into my pictures backup. So maybe I'll just give that a little path here, pictures backup, and then finally we need this little / semicolon. So when I run this, it should find all of the PNG files that I have and put those in the pictures backup folder. Before I do that, I'm going to just give you what the output's going to look like. So you'll see here are the pictures that we should be copying. This is what it found. So there's 5 of them total. And now if we exec that, so again, we're going to exec the copy command. We're going to pass in each picture to the copy command and move those to my pictures backup. And when I press enter, it finished. And if we go into the pictures backup in ls, you can see that we have all of our PNG files in this folder. As you can see with this pictures example, the find command with the exec option tagged on the end can be a very powerful and useful command. It's one of those commands that you're kind of just like, why didn't I ever learn this before? So I'll leave you with one more example of how you could use this, and then you're off to the races. You can go Google the usefulness of this command and come up with endless ways to use it. So the last one I'll leave you with, let's get back out into our main directory, is how to find all the files that are greater than 365 days old, and we could maybe remove those or put them in an archive. The way that we would do that is by saying find, give it a type of file, and then we pass in this little mtime option, which allows us to specify a number of days that we want to look for. So we type 365 and put this little plus in front of it to say that anything that's greater than 65 will qualify. And when I press enter, we're going to find all of those files that were last modified greater than 365 days ago. So all of these files would qualify, and what I could do is basically just redirect those with the exec command. I'm not going to actually do this because I don't want to, but we could type the exec command and then maybe rm. Be careful with this. I'm not going to execute this, but we could say rm, pass it in there, and then little / semicolon. And if I press enter right now, it's going to actually delete all of those files that just printed out. So as you can see, this can be a very dangerous command. I'm going to carefully backspace and not execute that, but you can see how powerful this could really be. Now the last command or set of commands that we're going to talk about is file archives and file compression. So when you download a software package off the internet, maybe off GitHub, and you want to extract it, or maybe you're doing this on a remote machine and you don't have the little file explorer that all you have to do is double click or right click extract all. Maybe you don't have that ability to do that, and so you're going to have to actually use the command line to extract or decompress a specific file format. So to do that, we're going to use the gzip, the gunzip, and tar commands, which I believe are built into pretty much any Linux or even Mac system. So if we come over to the command line, we're going to start out by creating a what we call an archive file. So if we go into the pictures backup folder, as we created a little bit earlier, you can see we have all of these pictures. The format that we're going to use to create this archive file is the following. So we're going to type tar, and of course you can always use tar help to get help with this command, but we're going to type tar, and then we're going to give it 3 little options here. So the 2 that we're always going to give it pretty much any time that we use this tar command is going to be v and then f. So what these 2 mean, the v means verbose, so it's going to print out what it's doing, and then the f means that it's the archive or tar file format. So we're always going to put that in, and what we're going to do is kind of switch up this first letter or option based on what we're trying to do. So we're trying to actually create this tar file format, so what we need to do is pass in a C for, I just think of it as create mode. So we're going to use tar cvf, and then what we need to do now is list the files that we want to put in this particular archive. So we can, or actually first we need to name it. So pick archive.tar. You don't actually need .tar, but I just put that there to signify what it is. And then we can pass in the files that we want. So we could just type in each individual file, or we could type the current directory and the star to access all the files. So let's press enter on that, and you can see that since we put in this little verbose option, it's going to print all of the things that it put in that archive. So if we ls, we can see that we now have a pick archive.tar, and to list out what is in that, if we just wanted to see like what's in your this archive that you're trying to unpack, we could type tar, and then instead of the C, what we need to do is the T, which doesn't actually make any sense. You would think like maybe it's like L for list, but it's actually T. So we'll do tvf, and we'll pass in the pick archive.tar. And you can see that it prints out the permissions, the owner, and some other information, as well as the file name that is in this archive. Alright, so we have created our archive. Now maybe we wanted to compress this and decrease the amount or the size that we have here. So right now this pick archive.tar is 542720. I think that's bytes. And if we compress it with the Gzip command, it's a lot easier. All you do is Gzip. Now let's see how big this is now. So we've actually decreased the size of this of all these pictures using the Gzip command. Now if we ls what's in our current directory, we're going to see that we have a .tar.gz. So not only is this an archive file type, but it's also compressed. So this is very common when you're like downloading software off the internet, or basically off of GitHub. A lot of the times you can download these, and normally if you just have like a file explorer, or on Mac the Finder, you just go in, you double click it, or you right click and do whatever it says, extract all, something like that. But if you're working remotely, like all you have is a terminal, you'll need to understand how to actually get all of the files out of this particular format. Now I'm going to do it in two different ways, and the first way is a very manual two-step process, and it's more educational. You'll understand what's going on. So the first thing that we need to do is take that .gz, or uncompress the file. So to do that, we use the gunzip, and then we pass in the pick archive.tar.gz. And what that's going to do is put it back to what we had it before, as just an archive. So that is step one. Now step two is to remove all the files from the archive. And the way that we do that, we can actually, I'm just going to demonstrate this by making another directory. So we'll say the directory is called extraction, and right now we have an extraction directory that is empty. So if we wanted to extract all the files, instead of passing a C for create or a T for list, we're going to say an X for extract, and then we want to add in the verbose and the tar format for which is F. And the way that we do this is we type in pick archive.tar, and then finally an uppercase C followed by the folder we want to put them in. And you can see we have actually extracted all of those files that were in the .tar archive, and we've put them into the extraction folder. So if we print that out, we're going to see all of the files in it. And you can see we actually still have this pick archive.tar. That will stay there until you pretty much delete it. I'm sure there's a command line option that allows you to delete it while you run it, but I'm not going to go into that. Now let's put this back into a gz format again. So let's say gzip pick archive.tar, and you can see we now have this same thing once again. Now the quicker way, rather than using the gunzip, and then the tar command is we can do it all with the tar command. So if we clear the screen and we say tar and then extract VF, and then we add this last little option Z in there, that will allow us to take the .tar.gz and just extract everything out of it. So if we pass in the pick archive.tar.gz, it's going to successfully extract everything out of it. Now, you're not going to see it because, we already had these pictures listed here in the directory. It's getting pretty cluttered at this point, but that is the one-step way to extract everything out. And of course, you could also pass that into another directory, and that's going to put it in the extraction directory. Of course, we already had those files there, but anyways, that is just the concept of archives and compressed file formats in a nutshell. This will get you going with pretty much any of your needs.